Alright, at this point we probably should cache the geometry. So let's create a file cache, and the geometry file, let's call that cliff. And well, we just need one frame, so let's get rid of that and save to disk. Let's load the geometry from the disk, so this way we don't have to recompute all the process of cleaning the geometry and everything. So let's add another cache for the underwater, save to disk, and load the geometry. Right. So that should be fine. Let's merge those guys just to see. Cool. All right, at this point, we're gonna start adding detail, but we're gonna need to generate some mask first. And that's where I created a tool called AL Mask Builder that you can find on my Gumroad. You probably maybe bought the tutorial bundle and it's included. So in here, we have enable slope, and just like we had for the height field, it allows us to generate an attribute based on the slope. So I'm gonna try to isolate the steeper areas, and also let's enable the height. So it's very similar to the mask by feature, but for geometry. Yeah, let's try to get something kind of like that. Of course, you're not forced to use my tool. If you want to create your own attributes by yourself, that's totally fine. And yeah, for me, this tool is just here to speed up the process because it's coming very handy to have everything in one toolbox. Yeah, so something like that would be a good base to start working. So on this, I'm basically gonna scatter some points. So let's create a scatter node. Let's just plug that, and no, not in group. Let's enable density attribute, and we're gonna call the attribute we created with the mask builder. So it looks like there's something wrong with using density as a name, so let's just use something else like scatter. Yeah, and that should work. Can of course disable the relax iteration if we want some more random results. All right. From here, we're gonna create a copy stamp that will allow us to copy and randomize some geometry on those points. So I'm gonna first create a sphere that I'm plugging the primitive input, and let's increase the uniform scale maybe. So it looks like I need to change the primitive type to polygon. And let's increase the frequency, initial size. So just, we got a bunch of sphere, that's good fun. We're gonna randomize the size using a attribute randomize. So let's use the P scale, and gonna vary that between 0.2 and 1.5. Cool, so we got sphere from different size. So I'm gonna uncheck transform cumulative. And let's stretch that a little bit maybe. Probably gonna apply some randomization in rotation as well. So in that case, in rotate Z, I'm gonna create an expression, random at point number, and we're gonna fit that value with a theta 1 between 0 and 360. So this way we got different variation of rotate Z, and same goes, we're gonna copy this expression in scale, but between 0.5 and 2 to stretch it more or less. And yeah, that should work. Let's deform all of this result with a mountain sop. Should probably increase the frequency first, and yeah, let's play with element size and height. So we are getting this asteroid look, so that's fun. Let's convert that into a VDB to get rid of the intersection and clean up a bit these models. Right. I'm also gonna convert to VDB the volume that we have. So it's like the third time we are converting it into a VDB, but no worries, it's normal. And we're gonna use a VDB combine. and that will act as a boolean basically, because we're going to change that to SDF difference, and it's going to carve or cleave. So we got some holes, kind of look like some Swiss cheese, or I don't know. Let's deform a bit more so that it's looking less like some cheese. Damn, that looks like a real cheese. So we are probably doing something wrong here. Let's probably change the element size. Yeah, that's better. It's better, I guess. We'll probably try at some point to bring different shapes and try different kind of look for these guys. But you get the idea. You can always play with the scatter if we want more or less of these breakups. So that's interesting, but having too much might mess up a bit the scale, and yeah, that's gonna be tricky. We'll probably do a few adjustments as we go. Let's keep going. We're gonna convert that into a polygon again. And actually gonna add another layer of deformation with another mountain. Yep. So basically trying to make it look like less like some kind of sphere. So some extra deformations, and let's convert that again into VDB. Like what we had before. Let's try to stick to the same voxel size too. And maybe more interesting. So we can always play with the size variation. If it's too much, we can always adjust max values. And yeah, let's convert that into a polygon. Cool. So it's gonna start looking like a cliff. We're gonna create another layer of breakups. Maybe we could play, instead of sphere, we could use a platonic shape. And we have a tetrahedron, octahedron, and dodecahedron, this kind of stuff. So in here, I'm more interested in this kind of shape. I'm gonna add some subdivisions because by default it's pretty flat and there's not much density to it. So yeah, now if we deform it, there's enough resolution. Cool. It's probably deform a bit too much, really. So this is the mesh that we have, and mountain is destroying it a bit too much. So I might need to adjust that. But let's see, let's keep going, convert that. Okay. So in the end, might look pretty different. I'm gonna copy the mountain and do a variation in here just for those guys. Okay, let's copy the VDB from polygon and let's plug the VDB combine. So that's pretty cool. We get some more interesting breakups, and in my opinion it looks less like some kind of cheese, and it could feel more natural. It really depends too on what kind of cliff you're making. Can vary from one reference to another, the type of the materials, how it fractures and stuff. So yeah, we got both options, and we're gonna clean that a little bit. Let's move this. We're going to duplicate this old setup. We're going to get rid of this sphere and use this platonic. So let's copy paste the VDB combine. So we get another layer of boolean, let's say. And that would be scatter A or B. And that would be scatter A. All right. So let's plug the convert VDB to the right spot, and yeah, we basically like are using the spheres plus the platonic distribution. So that's It's interesting. And try to balance things out so that's just not too much breakup. Yeah, from here it's sometimes you can find some happy accident and it turns out to look cool. Yeah, so it's just a matter of experimenting, really. Okay, let's re-enable that guy, see how it looks. Usually like to isolate my layers and figure them out individually before combining. Then when you combine, you realize, oh yeah, that's too much. Okay, so that's pretty subtle one. I think that could bring some interesting breakups. We'll probably keep experimenting and tweaking these values as we go. So we're gonna move on, and yeah, I'll see you in the next lesson.